Hello everyone, welcome to Shibi's chemistry classes. Today we are going to start the very first chapter of your class 10th ICSE syllabus, and that is periodic table, periodic properties and variation of properties. So in this particular chapter we have to cover this much content where we have to study about periodic table and its salient feature, some periodic properties we have to study in which atomic size, metallic character, non-metallic character, ionization energy, electron affinity, electronegativity. So these six periodic properties we have to cover in this chapter, and then we have to see how these properties vary in group and period. So that is trends in periodic property. So these contents we have to see in this chapter. So after completing this, we will take some questions of previous years, and we will do some practice work also. So let's start with the periodic table. So first we should know what a periodic table is. See, I have made it for you. You can see that it is a tabular arrangement in which sub symbols are written. So these symbols are H stand for hydrogen, Li stands for lithium, Na stands for sodium, K stands for potassium. So these symbols and their names you have already done in your previous 9th class syllabus. So you should be familiar with this. At least the first 20 elements you have to learn along with the symbol, name and their atomic numbers and electronic configuration of these 20, means up to calcium you have to cover. Okay, so first we will see what a periodic table is. Periodic table. So periodic table is the arrangement of elements in tabular form. It is the arrangement of elements in tabular form. Why we are saying tabular form? Because it is a type of table only, in which you can see some numbers written over here and some numbers written in horizontal form, so that we will see what they are actually. Okay, so periodic table, it is the arrangement of elements in a tabular form, and this is the modern periodic table. Modern periodic table. And who proposed it? Modern periodic table? Henry Moseley. Henry Moseley. So Henry Moseley proposed this modern periodic table, and earlier work of Newland and Daubeney and Manley, it was already there in your 9th class syllabus. So I hope you all know about that. But this is the modern version of the periodic table. We call it modern periodic table, and this particular table is proposed by Henry Moseley. And what Henry Moseley said, that the physical and chemical properties of elements are periodic function of atomic number. So this is the modern periodic law. So what Henry Moseley said, this is the modern periodic law. What we call it? Modern periodic law. So what is written in modern periodic law? That the physical and chemical properties of elements are periodic function of their atomic number. Now here you got a new term, that is atomic number. So now you have to see what an atomic number is, isn't it? Those who are watching my video, please note down the things along with me to get a better idea of the concept. Okay, if you will just listen, so you will not be able to understand anything. It will just vanish in air. So better, this is the correct way of learning things, especially when you are doing mathematics, when you are doing physics, when you are doing chemistry. So you have to sit along with your notebook and pen so that you can note down the contents simultaneously. All right. So what we have to see? We have to see what an atomic number is. Atomic number. So these are the terms you should know. Atomic number, we usually represent it with this Z, and it is the number of protons. You know the protons, electrons, neutrons. You all know this. So atomic number is the number of protons. Now what is protons? You all must be familiar of the structure of atom. So we will discuss the structure of atom first, then it will be clear to you. So I'm going to make structure of atom. Say for example, take hydrogen. Suppose this is hydrogen, and this is the nucleus of hydrogen, and it has one electron. So one electron. So this is the very simple structure of hydrogen atom. So whatever symbol we have written over here, it represents one atom of that particular element. H means hydrogen, but here in the periodic table, this H particularly represents one atom of hydrogen element, one atom of lithium element. See, we are representing only one atom, but it is not like that that particular element is made up of only one atom. It has n number of atoms in it, but here we are showing only one atom. Means whatever study we do, we study according to one atom only. Okay, so this is the structure of one atom. For example, hydrogen, and here you can see the numbers written in red. That is the atomic number. Here hydrogen has one atomic number, so it has one proton. Proton is positive charge species, and one electron. Center of this is the nucleus which is present in the center of the atom. Which atom? Hydrogen atom, and this is positively charged species. So this is proton. Proton is positively charged species, and electron negatively charged species, and neutron is neutral, means no charge, zero charge. This is neutral. And these three are called subatomic particles. Subatomic particles. So when we are drawing the structure of atom, atom is the smallest unit. Earlier it was considered that atom is the smallest unit, but further studies prove that no, there are subatomic particles as well. So these subatomic particles are proton, electron, and neutron. Where this proton is present? Inside the nucleus, which is present inside the center of the atom. So this is positive, and neutron is also present inside the center of the nucleus, but that is neutral. Neutral means zero charge, so that means proton plus charge, neutron zero charge. So overall charge inside the nucleus will be plus. Alright, so electron is negative charge, and it is considered that electron revolves around the nucleus in a fixed path that is called orbit. And this we will study later. So the electron revolves around the nucleus in a fixed circular path, and that fixed circular path is called orbit. So this is the structure of atom. But we have to study what an atomic number is. The atomic number is the number of protons. Means where it is present? It is present inside the nucleus. And one more thing, number of proton is equal to number of neutron. How they are connected? How these proton and neutrons are connected? A number of protons is equal to number of electrons. Means the positive will be equal to negative, then only the atom will be electrically neutral, and a positive balance negative. Positive and negative will be equal. But when there is an imbalance occur in this, and an imbalance means rearrangement or anything like that happens, then the atom become unstable or they become reactive. So that we will study later on. So I hope atomic number is clear to everyone. Please note it down, then we will proceed. So I hope you all have written it. Now we will come to the salient feature of periodic table. What we have studied right now, we have studied about periodic table, and we have seen the modern periodic table, who proposed modern periodic table, and modern periodic law, in which we have seen the structure of atom and the subatomic particles, how these particles are arranged inside the atom. Now we have to study the salient feature of periodic table. See, you can see this vertical columns, starting from number 1 to number 18. So these are the vertical columns. These vertical columns, they are called groups. First we will see groups. How many groups are there? Starting from 1 to 18. These groups are vertical column. This is, so we call them the first group element, second group element, third, fourth, fifth, sixth, and so on till 18th group element. And this horizontal row, they are called periods. How many are there? 1 to 7. They are called periods and they are horizontal rows. There are 7 periods in the modern periodic table and 18 groups. Now we will see one by one. First we will see groups. This is group 1. We call it alkali metal. The elements that are present in group 1, see, whatever element is present in this group, they have some properties in common. And so that is why they are placed in that same group. Hydrogen, lithium, sodium, potassium, rubidium. See, the position of hydrogen is not properly defined. Na? See, rest all are metals, but hydrogen is not metal. So exceptions are always there, but hydrogen is placed here, na? Because it has some properties similar to these elements. So whatever group, whatever elements are present in a group, they have some properties in common. These elements are called alkali metals because they form strong alkalis. The elements are hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. So group number decides the valence electron. Means all the elements present in this particular group has same valence electron. Valence electron. Now what is this? Now we got a new term again, valence electron. So valence electron is the number of electrons that is present in the outermost shell. Whatever electron is present in the outermost shell, that is the valency or the valence electron of that particular element. For example, alkali metals, I'll write one by one: hydrogen, lithium, sodium, potassium. This much is sufficient. Okay. Hydrogen atomic number is 1. Lithium is 3. Sodium is 11. Potassium is 19. So when we do the electronic configuration is the arrangement of electron in particular shell. And like shells, we know that K, L, M, N. Just now I made the structure of atom. So this circular path, it is the shell. K, L, M, N. And electronic configuration is the arrangement of electrons in this shells. So if you do the electronic configuration, hydrogen atomic number 1, the configuration is 1. Lithium 3, the configuration is 2, 1, because first shell can accommodate 2 electrons. So that is why we have written 2 and the rest 1 is remaining, so 1 here. Then 2, 8, 1. Atomic number is 11, so its configuration is 2, 8, 1. So you can see one thing common in this configuration. 1, 1, 1, 1. This is the common thing. It is present in group number 1 and its valence electron is coming out to be 1 in all the cases. If we go, here I have written up to potassium only. If you go to rubidium, cesium and francium, they all will have the valence electronic configuration of 1. And so what this group is deciding? It is deciding that all these elements have 1 electron. First group means 1 valence electron. Second group means 2 valence electron. Here 3 valence electron, 4 valence electron, like that. Means valency will remain the same. If we go down the group, valency will not change. Number of periods is changing. Shells will change. But valency means the number of electron in the outermost orbit. Here, the outermost shell, it will remain same in a particular group. Understood? So, group number decides the valence electron. You will get questions related to this concept. So, you should have a clear idea of the concepts. Suppose they will give you electronic configuration. They will not give you the name of the element. They will give you only the configuration. And you have to tell to which group this element of this configuration belong. Isn't it? This type of question, they will not ask you to give the name of first group element or give the name of second group element. No, you will not get a straightforward question. You will get questions like you tell the group number of element of this particular electronic configuration. So if you see the valence electron, it is 1. So immediately you will answer it belongs to first group. Okay, so first group elements, they are called alkali metal. Now we'll see second group elements. Group 2, alkaline earth metals. That means first and second group elements, they are metals. All right. Alkaline earth metal, what are they? Be stands for beryllium, then magnesium, then calcium, then strontium, barium, radium. So these are second group element. We'll see the configuration of this also. Beryllium atomic number is 4. So when we do the configuration, it is like this: 2, 2, magnesium 12, 282, calcium 20, 2, 8, 2. First 20 you have to learn. That much is there in your syllabus. Okay. So beryllium configuration 2 and 2, because its atomic number is 4, 282, 2882. So what you can see here, that it has a similar valence shell electronic configuration of 2. That means these elements belongs to group number 2. Group, when we are talking about group, we are talking about these vertical. We are not talking about this horizontal rows. Here only we are saying what about this vertical columns. Then from 3 to 12. This is not in your syllabus. The transition elements. Okay, so the elements from group number 3 to group number 12, they comes under the category of transition elements. They show variable valencies. So that is not there in your syllabus. And here you can see I have written 57 to 71, 89 to 103. What is it? If you look in your book, in your periodic table, you can see two table made below the periodic table, lanthanides and actinides. है ना? If it is made separately, that doesn't mean that it doesn't belong to this periodic table. Yes, it is there. But since there are 15 in number, 15 lanthanides and 15 actinides. If we make all that elements, if we include here in the periodic table, it will get a distorted shape. Na? That's why it is made separately. Alright, so lanthanide from 57 to 71 and actinides from 89 to 103, it is made separately. And you have to study them separately in your higher classes. So 3 to 12, they are called transition element. 1 and 2 group elements, they are all metals. They are all metals. These elements, they are metals. And you have seen their valence shell configuration is 1 for group 1 and 2 for group 2. So they are metals because they lose this electron while combining with the other atoms. When you study the chemical bonding chapter, you have to study this. Metals combining with non-metals. Why? Because metals lose electron and non-metals gain electron. These two group elements, they are all metals. They have a tendency to lose electron to become stable. I hope this much is clear. Now we will come to 13, 14, 15, 16, 17 and 18. Group 13, simple. It is boron family. Group 14, carbon family. Simply you have to study this. 15, nitrogen family. Why we are saying family? Because all the members of this family, they have some properties in common. They share similar properties. That is why we are saying family. And the first member is boron, so that is why it is said boron family. Here it is carbon, so carbon family. Nitrogen, so nitrogen family. Boron atomic number 5. Configuration 2, 3. Now here you can see that the valence shell configuration is 3, 13 group. 3, 13 group. Alright. Carbon family, carbon atomic number 6, configuration 2, 4. 14 group. Nitrogen 5. Sorry, nitrogen N, configuration atomic number 7. What I am writing. Atomic number 7, configuration is 2, 5. At valence shell configuration is 5. So it belongs to group 15. Oxygen, group 16, oxygen family. Oxygen family, oxygen atomic number 8, configuration 2, 6. And group 17, it is not fluorine. F stands for fluorine. But we don't say fluorine family. They are called halogens. Fluorine atomic number 9, configuration 2, 7. And the last group element, 18 group element, they are very special. Group 18, they are called noble gas. We'll take the first member, helium, atomic number 2, then neon, atomic number 10, configuration 2, 8. Here you can see that it has 8 electron in its outermost shell or valence shell. See, Here we are talking about valence shell electron. Valency I have not taught you. Valency we will see later. This configuration shows the valence shell electron. We are studying about groups. Group decide the valence shell electron, not valency. Okay, both are different because valency will change. So valence shell electron, here you can see that it is 8 and it is considered to be the most stable arrangement. Means all the atoms, they wants this electronic configuration. Means everyone wants 8 electron in the valence shell. So these either 2 or 8. 2 helium is having 2 electrons. It is having duplet arrangement. It is called duplet arrangement and it is octet. So either the elements wants to get this duplet arrangement or octet arrangement. Means either 2 electron in the outermost shell or 8 electron in the outermost shell. So if they do so, they will become stable and they will not react with any other elements. So the reactivity of the element is due to not having this electronic configuration. If the elements, that you can see that they are not having this octet or duplet. To do so, because all the elements, they want to be stable, they want to be in a state of stable configuration, and that stable configuration is obtained only by getting this 8 electron in the valence shell or 2 electron in the valence shell. So to get that arrangement, they chemically combine with each other, and they chemically combine with the other elements to get this arrangement. So this is about the group. So what we have studied that there are 18 groups. First two group elements, they are called alkali metals, and from 13, 14, 15, 16 and 17, here you can see metalloids also, and from 15 onwards they are all non-metals, and the 18 group elements, they are called noble gas because they are least reactive or non-reactive. Then what is left? Now we have to see periods. And yeah, one more thing, and what we have seen that periods in a particular group, the elements will have same valence shell electron. And if it is first group element, then it will have one electron in its valence shell. If it is the second group element, then 2 electron in its valence shell. Now we will come to periods. Periods 1 to 7 horizontal rows. This horizontal rows starting from 1 to 7, they are the periods. So you can see in first period, how many elements are there? 2 elements. Hydrogen and helium. Second period, 8 elements. Starting from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. We will not write neon because they have to be studied separately. They are special, so they will be studied separately. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Now we will write the configuration. Lithium atomic number 3, configuration is 2,1, beryllium 4, 2,2, boron 5, 2,3, carbon 6, 2,4, nitrogen 7, 2,5, oxygen 8, 2,6, fluorine 9, 2,7. I have written second group element. There are 8 in number starting from lithium till fluorine we have written. And we have written the electronic configuration also. So what common thing you observe here? So I'll write group 3 elements also, then it will be clear. Not group, third period. Again, they are 8 in number. Sodium. Let me check if the board is visible or not. Let me write it a little above now. Third period. 8 elements. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. Atomic number 11, 12, 13, 14, 15, 16, 17. Configuration 281, 282, 283, 284, 285, 286, 287. So I have written second period and third period elements, and you can see, observe it, try to observe what they have in common. Okay. फर्स्ट पीरियड भी लिख लेते हैं. हाइड्रोजन, एटॉमिक नंबर 1, हीलियम, एटॉमिक नंबर 2. Configuration is 1, configuration is 2. Because this hydrogen has only 1 electron and helium has 2 electrons, the configuration will be the same. So now try to observe what thing they are having in common. Like in group, we have seen that they are having common valence shell electron. Number of valence shell electron are same. What in elements belonging to a particular group. But here, what is same? Your valence shell configuration is not same. Valence shell electron is here. It is 1, 2, 3, 4, 5, 6, 7. So it is not same. It is different. Here also 1, 2, 3. Here also 1, 2. So valence shell electron is not same. But what is same? Number of shells. Number of shells means if it is an element of first period, that means it has only 1 shell in it. If it is an element of second period, it has 2 shells. K shell, L shell. KLM. Third period means 3 shell. You can see, you can count the number of shells from this electronic configuration. Here, only 1 electron. So, definitely it will be in first shell. Shell, I have already told you. This is the nucleus. And this path, orbit, in which the electron is supposed to be revolving, it is the shell, KLM. And so configuration, you can count the number of shells from the configuration. Here it is 1 configuration electron, 1 electron. That means that 1 electron is present in the first shell. So this hydrogen is having only 1 shell. Helium has 2 electrons. So it is not like that you can put 1 electron here and 1 electron here. No. A particular shell means the first shell can accommodate maximum of 2 electrons. So that is why everywhere you can see that 2 is written at the first. Second shell, it will accommodate maximum of 8 electrons. So that is why 8. And after 8, I have written the remaining electron here in the third shell. I have not written 9 here, na? Because maximum number of electrons that this second shell can accommodate it is 8. First shell can accommodate 2. So this is how you can do the electronic configuration. So what you can see from this electronic arrangement, you can see that third period elements, they have 3 shell. Second period element, they have 2 shell. First period element, they have 1 shell. Means number of shell decides to which period this particular element will belong. Understood? If you'll get, suppose you will get a question in which you have been asked to tell the period to which identify the period to which an element with electronic arrangement. Identify the period to which an element with this electronic arrangement will belong. This question I have made by myself only to make you understand that what is the need to study this period. है ना? So you can see here the electronic configuration is written over here, and what has been asked that you have to tell the number of period to which this element will belong. So immediately you will count the number of shell. Yes, it is 3 here, so it will definitely belong to period 3. And here you can see that number of electron in the valence shell, it is 7, so it will belong to group 17. Then you can count 10 and 17. Atomic number is 17. So which element has the atomic number 17? It is chlorine. So means you should be familiar with symbol, atomic number, and electronic configuration to answer this type of questions. I hope this is clear. So if we move on to period number 4, then it will have 4 shells, 5 shells, so on. Means this periods, number of period will decide the number of shell present in a particular element. Group से क्या पता पड़ रहा था? Valence shell electron. How many electrons are present in the valence shell? Now you should know shell and valency also. Shells I have already told you, but once again I'll explain it over here. Shells. So we call them orbit. It is a circular path in which electrons revolve around the nucleus. But if you see the element, you can't see the circular path. Everything is proved experimentally. If we look at this, suppose you have sodium metal. It is a very soft metal. If you look at sodium, you can't see this circular path or orbit or shell or electrons. Okay, all these things are scientifically proven. Experimental डेटा से ये सब एक्सपेरिमेंटली प्रूफ किया गया है कि ऐसा हो सकता है ना? हमको दिखाई नहीं देते हैं ऐसे, हमें कुछ इलेक्ट्रॉन मूव करते हुए और सर्कुलर पाथ और ऑर्बिट, ये सब कुछ नहीं दिख रहा है हमें. ठीक है. So shells, it is the orbit, shells or orbit, it is the circular path in which electrons revolve around the nucleus. This is the nucleus. Where it is present? It is present inside the center of the atom, and this is the structure of the atom. Why it is positive charge? Because inside the nucleus, protons or neutrons both are present, but since neutron is neutral species, it is not having any charge. Proton is positive, neutron is neutral, no charge at all. So overall effect will be of positive charge. That is why we say that nucleus is positive. But along with proton, neutron is also there, है ना? But since neutrons are neutral species, so that is why we take the overall effect of this positive charge protons, which is present inside the nucleus in the center of the atom. An electron revolves around the nucleus in a circular path, and that circular path is called orbit or shells. We show it with these numbers, these alphabets K, L, M, N, and so on. Next is number of shells. Number of shells we have to study in group and in periods. So how they change in group and period. So again we'll write the configuration of these three elements. Hydrogen 1, 3, 11. Configuration 1, 2, 1, 2, 8, 1. 281. Why I am writing it again and again? So that you can learn it. So configuration is done. What we have to see? We have to see the number of shells in group. What will happen to the number of shells if we move down the group? If I am saying group, that means you are moving down the group. ऊपर कुछ नहीं है, नीचे की ओर जाना है हमको, ठीक है? So when we are moving down the group, you can see that hydrogen has 1 shell, lithium has 2 shell, sodium has 3 shell. So if we move down the group, the number of shells increase. Number of shells increase. And periods, what will happen in periods? Second period, we'll take second period elements. Lithium, beryllium, boron, carbon, nitrogen, ऑक्सीजन, फ्लोरीन, है ना? इसी में वैलेंसी भी समझ लेंगे हम. 3, 4, 5, 6, 7, 8, 9. Configuration is 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, and 2, 7. So what is happening to the number of shells when we move along a period? When we move along a period from lithium to fluorine, do you see any change in the number of shell? No, it is same. Lithium is also having 2 shell. Beryllium is also having 2 shell. See, all the elements that belong to this second period, they have 2 shell and all are having the same. There is no change in the number of shells if we move along a particular period. Down the group, we have seen that the number of shell increase, but in a period it is same. I'm writing it again. Down the group, number of shell क्या होगा? Increase. And in period it is same. Next is valency. We have to see valency. See, you all are familiar with valence shell electron. And valence shell electron we have seen, it is the number of electron present in the last orbit or the outermost orbit. It is the number of electron present in the outermost orbit. That is the valence shell electron. But valency is different. See, valency. So what will happen? Valency, this is the valency 1, 2, 3, 4. So you can see that valency increase from 1 to 4. If the valency is 1, valence shell electron is 1, so valency will be 1. Valence shell electron 2, valency is 2. Valence shell electron 3, valency is 3. Valence shell electron 4, valency is 4. Valence shell electron 5, valency is not 5. The change is here. From 5, 6, 7. Means from 5 onwards. For 5, 6 and 7, 8. No valency, because it is having 8 electron. It will neither give electron nor it will take electron. So valency is 0. So we will deal only up to 17 group. So from 5, 6 and 7, that means nitrogen having 5 valential electron, oxygen having 6, fluorine having 7. We have taken one element of this particular group. Rest will be same. If we take carbon family, carbon, silicon, germanium, tin and lead. So configuration of these will be same, isn't it? 2, 4, matlab valence electron will remain the same na, for a particular group. Group mein valence shell electron will be same. Understood? So to explain, only I have taken the first element of all this, na, boron family, carbon family, nitrogen family. Rest all will be same. Valence shell electron will be same, so valency will be same in a group. But it is changing in period. Group mein valency will be same. This will have 1 valency for all the electron, 2 valency for all the elements, sorry, not electron, all the elements, 3 valency for all the elements, 4 valency for all the elements, but not 5 valency for all the elements. What you have to do? Maximum electron that can be accommodated is 8. So what you have to do to find out the valency of this one, means if you have to find out the valency for nitrogen, simply you have to subtract 5 from 8. 8 minus 5, valency will be 3. 8 minus 6, valency is 2. And 8 minus 7, valency is 1. So valence shell electron is different and valency is different. Valency is the combining capacity of that particular element. So its value is not positive or negative. Simply it has this value. You will not put negative over here, no? So that is why we subtract this valence shell electron from the maximum number of electron that a shell can accommodate. 8 होता है, 8 से हमने इसको माइनस किया, तो you get 3, 2 and 1. That means elements belonging to group 15, valency is 3, 16, valency is 2, 17, valency is 1. I hope this much is clear to everyone, and in the next lecture we will see the periodic properties and we see the trends, how these periodic properties varies in group and period. So till then, take care. Bye bye.